Create a hash table. Create a set. Yeah, that's the challenge, right? It's possible. So, yeah. Yeah, what do you think? Yeah, you can count, but I mean, yeah, what would you do with that? Yes. Okay, what would you do with it? How will you use it? So yeah, tell me the cool idea. Explain it. So you're saying something that could work. So you're gonna count every element. Is that what you want? So basically, what you're saying is we will go through every element in the array, and we will see if that element, how many times that element exists. Or you could say we don't actually care how many times it exists. We just care to see for every element we take it and we say it doesn't appear again in the array because we're not interested in the count of it. We're just interested to see if I look at my first element, and the first element appears again in the array, we try to duplicate. If not, then I look at the second element and check it with the rest. And then the third, and the fourth, and so on. I just keep looking at one element each time, all the way to the end of the array. So now I say, this is my idea. I will take one element and check it with the rest. Another element and check it with the rest. And in order to do this, I will need to do two loops. I will have a loop that looks to take each element individually, and then a second loop that will take each element and compare it with all the other elements in the array. So I will write this code. Now, of course, in the interview, I will be writing it line by line. And here I'm using Java. This is my first loop. I'm going to go from 0 to the end of the array. And then I have my second loop. It will go from the current index of the outer loop. And then at each step, I will check with I laser. And at each step, I will check the element at index I and index j plus 1. If they're equal, I return true. That means I don't duplicate. Otherwise, if I finish both of these four loops and never find two of them that are equal, then return false. Hold on one second. So one minute. So what is the complexity of this one? Always clear. Yeah. So this is the square, which is not great. I mean, it's good. This is a good starting point in terms of our approach. But can we do better? So we can't do that yet. But we said we can't use additional space. Remember, no, we cannot use additional space. So remember, now you guys are suggesting solutions that if you suggest them in the interview with the parameters the interviewer gave you, it would be bad because if the interviewer says you cannot use additional space, and then you go on and you go use a set or use a hash table or you copy the array, then it's like, wait a minute, I just told you, don't use additional space. So again, it's a reflection on, hey, what's going on with the communication? I said at the beginning of this, communication is important, and part of communication is listening. So you have to listen to the interviewer, and you also have to communicate your ideas clearly. So you have to ask questions, understand things, and also talk about the things you're thinking. So when you say don't use additional space, or you say don't modify the array, that means you can't sort it. So if you sort the array, you modify it. So now there's also a bug in this. Yeah, what about it? What is it? Yeah, so here A plus that box should be here. This is what happens when you go from Mac to Windows on your formatting breaks. So this box should be here, and it's to say J plus 1 here is going to give us an error. In Java, this would be an array of index and an exception, I think. And we basically, we're trying to access the element beyond the last element. So it will be a problem because j is going to go to length minus 1, and then we're doing j plus 1, which means we're accessing element that index length, which does not exist. Okay, so now, if we relax one of the constraints, we said the array is read only. We say, all right, you know what? Let's see what you can do if you modify the array. So we can say it's okay to modify the array. What will you do? How will you improve this? Yes.
We can sort the date and we do an input. And we take previous count pointer and current pointer.
Okay. Yes, very good. So in this case, the reason we are doing n squared is because for every element we're searching the whole array. So there's n elements. For every single one of them, we're doing n search. So n times n to the squared. And that's bad. But if we sort the array, then we don't have to search the entire array for every element to see the duplicate. Because if it's sorted, the duplicate will be right next to the current element we're looking at. So we simply can sort it, and then we can just check elements with their neighbors. Because if there's a duplicate, we will be guaranteed that it's sorted. Because if there's a duplicate, we'll be guaranteed that it's next to the neighbor. Hey guys, can you keep it quiet, please? Yeah, do you have something to say? Yeah, so in this case we say, all right, let's sort the array, and then we will write just a single for loop that's gonna check every element with its neighbor. This time we're paying attention that I will be less than length minus 1, so we don't overflow with I plus 1. And that's it. We just need a single linear for loop. So now, what's the complexity of this? Yeah, so this is now n log n because of the sorting. Now, somebody here asked me earlier and said, do I have to tell the complexity of the functions that I invoke, the common library functions that I use? And the answer is yes. Here, you see, our code actually is linear. Like this for loop is a linear for loop, and it will be O of n. But the overall complexity of the whole function is n log n because we're calling a sort function, which is n log n in the best case. So that's n log n. Now, how many people here are Java developers? Okay, only like 4 people. So from these 4 people, there's a bug in this code as well that only if you're a Java programmer or comfortable with Java, you will know it. Can you see it?
There is no such a function that sorts.
Yeah.
Because I remember there is sort.
Exactly. Yeah, exactly. So in Java, you can't do a dot sort because a is the type of a does not support this kind of function. So the way you would sort an array of this type in Java, you have to do arrays.sort. And this shows here, the reason I'm showing you this kind of problem is because if you write this code in the interview, and the interviewer is familiar with Java semantics and Java functions, then they'll say, wait a minute, why are you writing this? You should know that this doesn't work if you're a regular Java developer. So this is to say, know your language and use the one that you're most comfortable with, so that you don't confuse yourself and the interviewer when you're doing this. Okay, now final step here we'll say you can use extra space. So we'll relax another constraint and we'll say it's okay to use extra space. How will you do this if you're allowed to use extra space? Yeah.
We can use hash tables.
Yeah.
For example, for the first loop, we will check every element, and if this element is not existing in the hash table, we will put it into hash table. But if it exists, then we return false because we found it.
Yes. Exactly. So if we use a hash table, then remember, going back to the first solution we had, for every element we're looking at, we're searching the array again that we have n squared. So for every element, we have an O of n operation each time. But we can come up with a mechanism that has a faster search. where we can look things up in constant time. Hash tables allow us to look things up in constant time. So instead of searching the array each time for every element, we can search a hash table, and hash tables are a more efficient way to search. So we will save ourselves that second O and term, and we will only just need to look at all the elements. For every element we look at, we say, does it exist in the hash table? If it exists, that means we've already looked at it before, that we have a duplicate. If it does not exist, then simply add it to the hash table and keep going. So the code becomes like this. So now we're using JavaScript. We're initializing empty hash tables here, which is empty object, and we're using this for loop, simple for loop. We're checking if the hash table contains the current element. Hash table is called C. This is for the element already C. If it contains the current element, return true. Otherwise, just add it to the hash table and set the value of it true and keep going. And if we complete this for loop without ever entering the true statement, that means we have no duplicate, so we can safely return false. Now, what's the complexity of this? So all of it in terms of time, because we only have a linear for loop that is doing that's happening n times and doing constant work. What's the space complexity? What are we? Raise your hand. Yeah. Yeah, it's also then because we're using a hash table, and the size of this hash table can be as big as the original array. So as a result, we say the number or the amount of additional space required is equivalent to the size of the original array. So we say it's all in time and all in space. And it's the formatting breaks. Okay, so now you've seen three different ways to solve the same problem. Each of them has different performance for space, time, and they also have different constraints for whether we can complete the array, or sort of whether we can modify the array, or whether we can use additional space. Any questions about this? Yeah. What's that? Why did we use an object? Well, this is just in JavaScript. This is how to use a hash table or a thing with a key and values. You could use a map if you want. But if you're familiar with dictionaries in Python, what do you call them? Map, people put the same idea. You could use a head, you could use a set too. But underneath it, the set is the same as the hash table. More or less under the hood, the set is similar to the hash table with dummy values. Yes. Yeah. Very good question. Yeah. So you asked, what is the best way to start solving the problem? And really, starting simple is a winning approach too. Like, don't try to solve the problem with the most complicated solution from the start. Try with something simple, and then see if you can iterate. Now, let's keep in mind, sometimes if the problem is already so simple, using the simple solution maybe is not acceptable because maybe the simple solution is very trivial and too basic. So maybe you need to do better from the start. But it's a good place to start a lot of the times to go with the simple. Now I see people leaving. Do people have a class?
Maybe it's prayer time.
Oh, class with prayer then?
Do we have like how many hours?
Well, then we can wrap up soon. So now I want to say the question I gave you here is this is too simple of a question. I've shown it to you here as an example so that we can just kind of play with it because there's three different ways to solve it and different constraints. But let's look at something a little bit more real, and we can, if people have to go, feel free to go. But I'll share this question with you, and I'd like to, people have time to stay. I'd like to give you a chance to try solving it for a few minutes by yourself, and then we can solve it together. What's that? Well, let's look at it. Let's look at the test. Oh. Yeah, we haven't got it. There are ways to Okay, so this one says, give it an array, write an algorithm to move all non-zero elements to the end of the array, to the left of the array. So give it an array, write an algorithm to move all the non-zero elements to the left. So yeah, so here are some questions to ask about the very one. Does it only contain numbers? We'll say yes, it only contains numbers. Can we use extra numbers? Or does it have to be enclosed? In this case, I will say don't use extra numbers. Yes, but that? Okay. Yeah, so this I'll ask this quickly. It's a little bit outside the topic of this question. It was which language do you recommend to learn first as a beginner? And the answer is there is no right answer. Just pick something and start learning with it. It doesn't matter. Everything will be helpful. Everything will be useful to learn. So maybe people will tell you Python, you can your production, whatever. Pick something and start learning, and then stick with it. In the end, when you start working on a project, you'll have to learn the language of that project. So all the time you're learning new languages. But as a beginner, try to pick something simple. Maybe Python is easy, or Bash is easy, or other script languages. It could be a good place to start. Okay, let's get back to this question. So, can we use extra memory? We said don't use extra memory. No, don't. Try not. We don't. We never want to use more memory over time, right? We can do it without. So what goes on the right side of the array, where the non-zero elements were? So in our array, so normally this question I give it an easy. I asked this question twice. So this is a real one, and it's if I write here, you can see. So if the array looks like this, then we want to move the non-zero elements to the left. So we would think it should look like this. And now we're saying the non-zeros are on the left, so we completed the requirement. But what do we want to be on the right side? Do we want to put the 0, or what do we want? So actually, in this problem, we don't care. For this value, you could leave it the original value, you could put 0, you could put null. We don't care. We just want the left side of the array to contain all non-zeros. And we want to return the number of non-zeros in the array. So in this case, this will return 3. Because we have 3 non-zeros. We move them all to the left, and we return. So does the order matter? So do we want to keep the same order of the elements, or it's okay to change it? And we will say here also it's okay to change it. We don't care. And here finally, what is the runtime? As usual, always try to find something that's better than O(n) squared, if possible. But sometimes maybe not. So I'll give you maybe 5 minutes to just try solving it. Can you modify it? Yes, you must modify it because we're saying the array has to be modified so that you move the non-zeros to the left. So you must modify it. If you don't modify it, you're not solving the problem. Yes, but
What if you modify the sign? Just do it.
Yeah, well, just think about the complexity of deleting elements. What is the complexity? So think about the solution uh, before you start talking. Yeah. Yes, if you can do it in constant. Yeah, just take a minute. So let's take 5 minutes, think about it, solve it on paper, or solve it on your computer, whatever, if you want to give this a chance. And then we'll come together. I will answer the questions individually, so I don't disturb people who are trying to focus. All right. Okay. Let's do this. Let's see. Uh, some people look like they just want to TikTok, but some people look like they were voting. So let's see what you guys came up with. So, do you have a question or you want to share an idea? Oh, you have a solution. All right. Somebody's going to get a job today. All right. Let's hear it. What do you got? It's N squared. Okay. Okay. Okay.
That's why it's
Yeah.
right. Don't.
Okay. So now remember, this is a problem that is telling us to move, non-zeros to the left. If we can do that, we can sort the array, and sorting is involved. But this problem should be easier than sorting. So if we're doing n squared for a problem that is easier than sorting, that's not good. We wanna find something better than sorting because the problem is easier than sorting. So we should be more efficient than sorting. Because if we're gonna do worse than sorting, then we may as well just use sorting and have our sorting condition being 0 and not 0. So I see some other ideas. Let's see what you got. Yeah. Okay. Yeah. Yes.
And if we find real number,
Yeah, that's exactly right. So this is actually the perfect answer to this problem. And she just described. What's your name? What is it? Elvira. Is that right? Elvira? Yeah. So she's talking about. Here's talking about going through the. Let's find some example that is a little bit more interesting than the first one. Is there a better pen than black? The red letter show. So if we look at the array, let's say we have, remember, we said a big part of the solution is actually step 3. What is step 3? It's when you can describe the solution just like how she did it now. And that's the hardest part of the interview. Is being able to describe and synthesize the solution in your mind. Once it's clear and synthesized well in the end, you can code it. The coding part is not the hardest part usually in these kind of problems. So if this is our array, let's say we have 1, 3, 0, 7, 0, 9. So she's saying we will start from the left and the right. So we can have something going from the left, we'll call it I, and something from the right, we'll call it J. Now, I'm going to solve this problem, or talk about how to solve this problem, like you would want to in an interview. So when you come to an interview and you have this kind of problem, you solve it in a way and describe it in the way that I'm putting it down. This will be considered a very good solution. To describe the solution, first, obviously, you ask questions, you read the questions, ask questions, think about it, describe it. You show a sample solution before coding. You show something, and then you code it. So here, we're doing step 3 right now. You say, okay, I will go through this array from the left side and from the right side. I have 2 pointers, and I move the pointers toward each other. The left will move to the right, and the right will move to the left. And at each step, I will check what the pointers are looking at. So when the left pointer is looking at a non-zero, we just keep moving because the non-zeros on the left are a good thing. So we keep moving forward until the left pointer finds a 0. When you find a 0 on the left side, now we say, okay, hold on a minute, that's a 0 on the left, we want to replace it. Then we go to the right side, but we don't go, we're always on the right side and left at the same time. When the right side is moving, if we find a 0 on the right side, we say, that's good, 0 should be on the right. We keep moving the right pointer until the right pointer is now looking at a non-zero. We say, hold on a second, we have a non-zero on the right side, we have a 0 on the left side, let's swap them. And we keep doing this until the 2 pointers meet in the middle, and we say, we've completed it. So, to demonstrate that this actually works, now I explained the approach, just in theory, but let's prove that it works for an example, still before coding. So we'll go, this is my I will start by moving my I. So I move I here. This is a non-zero on the left. It's a good number, we want to keep it. So we move I to the next position. Still, we have a non-zero. It's good. Let's move it. So now, I is pointing to a 0 on the left. J will start here. So this is J. Already, J is looking at a non-zero. We said non-zero on the right side is bad. So now, we have 0 on the left, non-zero on the right. So we say, okay, let's swap these. So we make this 9, we make this 0, and we move I to J. So now I is looking at a non-zero. We say, no, non-zero is fine. Keep going. Now I and J meet each other. So we say, okay, we finish. So this is actually, what is the complexity of this solution? So all then in time, because we will only scan the array once, and we don't actually use any additional space. So the solution will look like this. So now this is in Python. So we're jumping between languages. So the left, we initialize the left, I called it I, but the left initialize the 0, initialize the right, the last element of the array. Then we write a while loop, while left less than right, less than equal. This problem it could be less, doesn't have to have equal. So we want to make sure they have not met. Then we check if array left is not equal to 0. If it's pointing to a non-zero, like I said, we just keep it because non-zero is not a good thing to us. So think of that. If array right is pointing to 0, also it's good for us to have 0 on the right. So just keep the right pointer moving towards the middle. Otherwise, if both of these are false, that means the left pointer is now pointing for 0, the right pointer is pointing for non-zero, so we'll enter this situation, and we will just switch the right to the left, and we will increment. Now, notice, we're not actually assigning value to the right side, because we said, we don't care what happens to the right side. We only care that the left side has the non-zero. So here, the right side will just take values that are not interested. And that's it. So the solution here is not that complicated in terms of code, but coming up with the idea is the hard part. And once you have the idea, then coding it becomes easy. Any questions about this? What's that? Right. Yeah, they're missing right. Yeah. That's a little typo. Okay. So do you have any final questions? We can wrap up shortly. Any final questions about this or anything like that today? Or you guys just want to go home and play some PUBG? Do people play PUBG? That's what people play in Iraq. They play a lot of PUBG. Is it famous here too?
Yeah. What about you initialize reference, right? Okay. For example, in this array, that must be 9 goes to the third place. In third index in array, yes, 9 goes. But 9 also stays in the last. Yes.
Yeah. Like I said, we don't care about what happens on the right side. So this example actually, what will happen is this will stay 9.
Yes.
So this will stay 9. And like we said earlier, remember that slide that said what goes on the right of the array where the non-zero elements were? And I told you guys on the right side, I put a question mark because we don't care about what's on the right side. We just care that all the non-zeros are for that.
The only thing you must do is that the numbers must be non-zero.
Exactly. So all the non-zeros are for that. Yeah. Okay. So at this point, we can say it's yeah. How do you get the interview? Do you remember my slide that said you can watch that like or the recording? Basically, there were 6 or 7 things I talked about that could be opportunities to get attending this event, writing blog, posting or participating in hackathons and so on.
But one thing, but we cannot straightforward go just apply for
You can apply online, but like I said, there are millions of people that apply online. So how will you be different? This is how you become different. You come here, you go to the hackathon, you go to the conferences, you make yourself different. Imagine all the people in India that are applying to jobs. How many people in India? In China, there are a lot of people applying to positions. A lot. There's 7-8 billion people in the world. So how do you make yourself different from the other applicants? Yes. I didn't have any references. Referral. Yeah, I didn't have referral, but I got. So you can do it without a referral. Yeah, it's possible, of course. Yeah, yeah. Yes. I worked at small companies before. Well, I worked at a local startup where I went to college, and I worked. I just did some projects here and there. I also worked at IBM, which is now not a IBM is not very it's not a very huge company. It's big, but it's not as exciting as Google and Microsoft, Apple, Amazon. But I worked at IBM. I worked at another company, and then I worked at this. Okay, I want to share with you guys one last thing. It's not the whole coding. See how many clicks I get. So many slides. This is the boring stuff. Final tips: practice on a whiteboard. Leave white space between questions. So if you're writing your code, leave some white space. Time yourself. It's very important to time yourself and practice with somebody. Have a timer. Remember, we set the time. It's one of the hardest things time management. If you're doing code review, make sure you have a good connection. And use headphones. And I said this already. We had a friend to do a mock interview. So now after this, there's like 250 people here. Go home and find somebody next to you. Say, hey, give me your number. Let's meet up and do a mock interview together. Okay, so I want to share this final thing before. So this is a quote. It says, "There are better starters than me, but I'm a strong finisher." You know who said this? Anybody know who said this? You don't know. It's this guy. He runs very fast. He's the fastest person. Yeah, it's Usain Bolt. So maybe here he's talking about running, racing. You know, he's saying there are better starters than me, like people who start the race better than me, but I finished the race strong. That's how I win. That's how I have all the records in the world. I'm number one by finishing strong. And I think it's a metaphor for life, not just for running. So if you think about all of us here, there are nearly 200 people, maybe a little less, and each one of us has a different background. They come from different family. Some of us have more money than others. Maybe your parents have connections in the universities or the government. Maybe your cousin works at Google and they can give you a referral. I don't know. We each have different privileges, different beginnings in our life. And maybe most of us here are not very privileged because I'm from Iraq. A lot of you are from Uzbekistan or Tajikistan or this area. We're not from Europe. We're not from America. We're not from the best countries in the world. And we might think, you know what, this is hard. Life is hard. And we don't have a lot of opportunities. We don't come from rich, developed nations that are influencing the world. And you say, you can't have big dreams because of where we started. And this is how I used to, because I come from Baghdad. I grew up in Iraq during the war, when the country was being destroyed. I go to school and I see people dying, I see bombings, I see shootings, and I used to think, I can't even have a normal life. How will I ever be able to have a job or have dreams and live a life that is stable, or even dream big and have ambitions to build a company or work for a company or build a life that is interesting when I'm just basically trying to survive. I always used to feel, because of where I started, because of my beginning, I will not be able to get very far in life. I used to look at other people around me, even from back home, people who have more money. I come from a family that's not very rich. People had parents that were working merchants and entrepreneurs and doing things that gave them a lot of money. People who would go to vacation, international vacations every year in the summer, they spend it in Europe or they go to Malaysia or somewhere. I don't know. And for my family, none of this was possible. And when I started going to university, I mean, people from other parts of the world, and I would think, I can't work at Facebook. I can't work at any of these companies. I'm not good enough. I don't have the background. I don't have the early education that these people had. You know, they would spend their vacations in Paris when they're 2 years old, and they would go and you do a Euro trip in their high school and all of this stuff. But I can barely speak English, and so I used to think a lot about how I had less of a privilege. But I think about this quote, and I think about how Usain Bolt talks here about how he doesn't have the best beginnings. He's not the best at starting the race, but what matters more and what helps him with every race and come first is how he finishes it. And we think about our lives and where we start and our beginnings. And it doesn't matter. Some of us will be a little bit behind where we start. Some of us will have less money. And maybe we don't even have parents. Maybe our parents are not around. But it doesn't matter because what matters is how hard we work, how consistent and persistent we are, how many leak code problems we solve, or how many hackathons or coding competitions you go to. All this hard work that you do is what matters. It's what helps you get ahead. So remember this quote, especially if you feel like I used to feel. If you feel that you're not going to go far in life because of where you started, challenge that thinking. Tell yourself, don't put a limit on your dreams. That you can do whatever you want as long as you work hard and you put your heart and your mind into it. It doesn't have to be that you aspire to work at Facebook or Google, or maybe you make the next Facebook or Google. You know, we come from a place in the world where we're now in a place in the world where we can do anything we want. We have the technology and the infrastructure to help us create change. So if those are your dreams, don't let anybody take that away from you. So thank you so much for being here and for listening. Let's take a group photo. Yes. All right, come on up. Let's.
women into